Hello guys, this is Asim, and here I came back with a new problem. So this is a very famous problem. I mean, you need to find the redundant age. So quickly go through this problem. I'll share the link as well. So I'll make you understand what the problem is. Okay, so see, this is a problem. This is a graph, and you can see there is a cycle in this graph, right? But what do you think? If I remove any one edge, will that make a tree? See, does it make tree? Yes, it is making a tree. So, what is a tree and what is graph? Now tell me. See, simply the tree. See, every tree is a graph, but not every graph is a tree, right? This is a tree. Fine. So simply a graph. See, in a simple word, what is tree? A tree is simply a graph which do not have any cycle, right? That is a tree. That's cool. Right, let's move on to the problem. So what is the problem? Problem is that a graph is given and you need to remove any one edge such that it makes a tree, right? And the question is not that too simple. Actually, it is saying like that you have given a graph that has a node, right, and one additional node. That is a node which is making a tree to graph, right? That is the additional node we are saying. So yeah, we need to find the edge that can be removed so that resulting graph is a tree, right? And if there is a multiple answer, then return the answer that occur last in the input. This is the input, and you need to return any one edge which is making a tree to graph, right? And this can contain multiple answer. Even I remove this edge, this will make this graph to tree. If I remove this also, if I remove this also. So which one to take? Which edge you need to take? So this line make it clear if there is any multiple answer, just return the answer which occur last in the input. So out of all these edges, I need to return the edge which is coming in the last in this input, right? So you can see as like 3 2 we have here is a edge which is last in this input. Let's try to go for another example. You will understand it better. So again, you can see this is a graph, and it is one other like another cycle, right? If I remove any one edge, either this one, or in this one, or this one, this can make this graph to a tree. Cool. So in the category of removing any edge, all this edge comes in my category. No, I can consider any one out of out of all this four edge to remove. I cannot remove this edge. Can you say why? First of all, if removing this edge, will this make a graph to tree? No, it will not make a graph into tree. Another is that if I remove this edge, still there is a cycle in this graph, right? So I can't remove this one. So if I consider this 4H in removing, which one to remove? So I'll take input. I'll start from backward and I'll go through the input which is in my consideration. Is 1 5 is in my consideration? No, it is not in my consideration. Is 1 4 is in my consideration? Yes, it is in my consideration. That is why we are returning output as 1 4 because this 4 is considering, and this came in my second last place of the input. That's why I'm removing it. But how to solve this question? See, the simple way to solve this problem is that first of all, you need to find the cycle in the graph, right? If we found cycle in this graph, then what we'll do? We try to store the parent. Suppose I start with 1, I go to this 3, right? So moving on from 1 to 3, I will store the parent of 3 is 1. In the same way, if I go from 3 to 2, I'll check if 2 is not visited. marking 3 as a visited, then I'll go for 2. If 2 is not visited and we know parent of 2 is what? One parent of 2 is what? 3. I'll store it I will take one some vector array, right? Okay, I'll store, then I will move to from 2 to 1. When I move to 2 to 1, I found that 1 is visited already. And if it is visited already, then what is the then we have found cycle, right? If I found the cycle, then I'll start from this very last node, which is 2, and I'll try to move on from this node to back it to its parent and checking the input, because whenever I got any node which is making a cycle, that means whole of this journey in whole journey there can be all edges which we can consider in removing the edge, right? So I'll consider this as well, and even this. So I'll try to move back with the help of parent vector, and I'll check in the backward direction from the back of the input whether this edge is in my input or not from the backward side. If it is if I found that edge is in my vector, that is input vector, then I'll return from there itself that this is my edge which I need to return. That's it. Nothing big problem. Okay, so let's try with another example. If I start with 1, I'll go from 1 to 3, marking 1 as visited. And parent is what? For parent of 3, we have 1, and it is visited again. From 3 to 4, I'll go to 4 and mark as visited. And what is the parent? Parent is now 3. Now I'll move to its child, and which is 2, and I'll mark 2 as visited, and parent is 4. Now I have two children, 1 and 5. I'll go for first 5 and mark it as 5 as visited, and parent is 2. And then I'll go for its second child, which is 1, and I see that it is already been marked as visited. Now I found a cycle. The, at the time when I found a cycle, I'll move back and I'll check whether that age is in my input vector or not from the backward, because I need to get the last possible answer, right? So yeah, that's it. That's what I'll do. I'll check whether 2 or 4 is in my input or not from the backward. Not 2 4 actually. Yeah, this yeah. I've taken the same example with different nomenclature. Nothing big. So 1 4 is in my vector. Yes, from the back it is in my vector. That's why I'll remove it. I am considering this example. Okay, so yeah, let's move on to this solution. See, this is a number of nodes. Now, I'm taking one adjacency list as a global value right here, and a vector of parent as I told you, and visited as a bit set, right? You can take it, and I'll make a adjacency list of this given ages, and I'll try with DFS from the very first node, right? Whenever I go for any node, I'll mark it as visited, and I'll move to its child. And if I'll check if that is not visited, if that is not visited, I'll mark its parent, and I'll go for that node. I'll try to move for DFS for that node. If it is visited, then I'll check whether it is a parent itself or not. If it is not, and again, if I found, I'll take one counter variable which is found, which will tell me that I have already found a cycle or not. Whenever I see that found is -1, that means I have not found a cycle. That means I'll go inside and I will update this font as what? As my current node, and I'll again mark a parent of that node. right? So in this way, I'll come out of this DFS and I will start do while loop with this font itself. I'll check, move, I'll mark all the vectors which can be considered in my cycle, right? I'll mark all the nodes which can be considered in my cycle. So right, I have taken one more vector which is the cycle here. This is this vector. Yeah. So I'll mark whole of the nodes which is can be considered in my cycle, and then I will try to move in from the input in the backward direction, right? In the backward direction, I'm moving, and at the same time, I'm checking whether this node is cycle or not. This edge can be considered in my cycle or not. If that edge is what the node is considered in my cycle, then I'm returning that edge itself. That's it. Nothing big. So yeah, that's the solution. Thank you.